Let me start with the live question today. Count number of teams. Let's not the timer. There are 10 soldiers standing in a line. Each soldier is assigned a unique rating value. You have to form a team of 3 soldiers among them under the following rules. A team is valid if uh, rating of I less than rating of J less than rating of K, or rating of I less than greater than rating of J greater than rating of K. Return the number of teams you can form given the conditions. Soldiers can be part of multiple teams. So whether it's strictly increasing or strictly decreasing order. 2, 3, 4, 5, 4, 1, 5, 3, 1. 2, 1, 3. It's not possible. 1, 2, 3. 2, 3, 4. And 1, 3, 4. 2, 1, 2, 3. 1, 3, 4. 1, 2, 4. 2, 3, 4. 4. Okay. So I think mm, let's say we know the answer for let's say ratings are numbered from R1 to Rn. We know answers for R1 to Ri. Let's say a new rating number came up, Ri plus 1. How will this change the dynamics? Let's see. This is induction, and this how adding Ri plus 1 will change the dynamics of number of triples. So first of all, Ri plus 1. What if there is, we know, K between, which where Rk is greater than Ri plus 1. Do we know the range of numbers? I think range is between 1 and 10 power 5, n is between 3 and 1000. So what are the edge cases? Edge cases would be n less than 3, because n equal to 3. I think there's only one possibility, either increasing or decreasing, otherwise it's 0. Okay, let's say we know an Rk greater than Ri plus 1. Um, now quitting this. Okay. So for each of the element, what if we know Ri is greater than Ri plus 1? Let's say we know for Rk, number of elements, some elements greater than Rk, and where index less than K. That will be x. For each rk, we can get xk. So what if I do that? If ri is greater than ri plus 1, we already know xi. So xi plus xi minus 1 plus and so on. This requires additional storage of xi's, but how to find xi plus 1? So basically xi times ri plus 1 greater than ri. Ri plus 1 greater than ri minus 1 and so on. Xk times ri plus 1 greater than rk. If it's this, basically independent I of this, which means if condition is true it's 1, otherwise 0. So this algorithm is each iteration takes off in time, and there are n iterations of in square time. First let me quickly implement this. Let's say x greater elements. I think we should do this, and also similarly we need to do less as well, right? Are all elements distinct? Is it true? Okay, all elements are unique. So I thought this number of elements less k is yk. Y star ri plus 1 less than r. Sum of these two. And if you know xi, you know yi, because it should be number of elements less than ri plus number of elements greater than ri should be equal to I minus 1. Number of elements less number of uh, number of indices less than I, that is. Let's do this. So let's calculate for this greater greater array, which is empty. Initially there's just r1, so number of elements greater than r1 will be 0. So let's start with 0. R and let's say current. We need to find the current. Number of times ri plus 1 is greater than this. Is we're aiming for ascending order. Such something like this maybe. xi array plus 1 should be greater. Yeah, left greater. That means it's left lesser. Array current 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 left lesser 0. Let's enumerate over rating. Current rating. Let's use camel case. For if I need to iterate till index minus 1 for left, this is k in range of 0, index. I think it goes till index minus 1. Yeah. If rating of k is less than current rating, then current rating plus equal to 1. From this, then now to find the answer equal to 0. Answer plus equal to okay. Left cluster of k. I think if rating k is lesser, left lesser flag. I think we can have is the left, is it a left lesser? False. True. If the kth one is left lesser as it was point more elements less than k times limits on, else answer plus equal to k minus 1 minus f lesser k. So I think while iterating for the first element, you can assume that maybe the base case is solved at 0. Anyways, let's say first, let's say 1, 2, 3. First element 0, left lesser 0, nothing gets added. After that, for 2, for 2, C is 1, left lesser 2 less than 1 less than 2, so 1 is left lesser. Oh, should I do all this? There may be a good better way, but let's do this for now. Return answer. Answer 2. So left lesser is 0, 0. But k minus 1 is also 0. 0 minus 0, 0. 3. Left lesser is 0, 0 is 0. Anyways, but for 0 it might be wrong, because 0, 0 minus 1 minus 1. Okay, k is here. In the case, should start from. What's the point in comparing it with 0 to 8? It's just waste of time. So I will start from 1 toward the edge case. Start from 1, 1 minus 1, 0. I think it's still k. Yeah. Let me start from 0. K. Number of elements. K is indexed from 0, so k. Yeah. So 0, 1 for 3. You see 0. 0 is 0 minus 0, 0. Okay, ignore that. But you see that currently lesser is 2. Is 1 at least. 1 plus. For 2, you see again 1. Answer plus equal to 1. It's a 3 to 1. Again, answer plus equals to k is 2 minus wait 1 2 3 it's fine. This is one circle or 3 to 1. After 0 please, and 0 as well. My answer would be 0 minus 0. No. What of elements? 0, 1. 1 minus 0. 1. Answer is 1. Yeah, I think it is good. Let's see. Submit. Okay. This often square. But I think this. Let's see if it has an often. I'll go. Often I'll go. So okay. Let's see. Xi plus 1. Sorry. R1 to Ri. Ri plus 1. Ri plus 1. Xi is the number of elements less than Ri plus 1. Less than Ri. Less than Rq. Ri plus 1. Less than Rq. So only one of them is true. What if, let's see the hint. Brute force check all possibilities. What the heck? Oh, I think it's fine. Let's see the editorial. Okay, there's a fan victory. Let me read it later. Alright, let's see the space complexity. Can optimize the space complexity. Left. Now high ratings. Okay. What if I assume it to be a middle number? Ri plus 1 to be a middle number. Okay. Number of possibilities. Let's say x. X here where Ri plus 1 is a middle number. Similarly, plus 2 star y. X2 star y2. How can I calculate x and y? Without moving algorithm. Okay, I think at each point I can calculate how many are greater and how many are lesser. Yeah, that's a better algorithm. So, see this array. And we're adding it in between. Simple iteration. Yes, I'm skipping the family tree. Middle element. Traverse left and right. Okay. Okay. How to do this with induction? So xk is the missing element. We add xk. Or we can do it this way. x1, xn are there and all else are missing. Add x2. How can I solve it for x2? We will change. We add it. We know that x1 and xn will be the first and last elements. Any of those, they can't be middle elements. So upon adding x2, just see number of elements that are less than x2 and number of elements in the right of x2 that are greater, and just multiply them. Similarly, greater than x2 to the left and less than x2 to the right, multiply them of one space. Now we add x3. So considering it as a middle element might be useful. Fine. That's all for the lead code question. We will go to system design. Um, last time where did we stop? System design development. Okay, here. Okay, let's continue this tomorrow.